Do you remember what introduction to sets? What is a set? Well, simply put, it's a collection. First you specify the common property among things, and then you gather up all things that you have a common trait. For example, there is a set of shoes, socks, pants. There you may have a lot of pants, you may have a lot of socks, shoes, socks, hat, and so on. You have to put that, if you put it in a set, you will be putting only the common. Gather up all things that you have this in common trait. Okay, this is known as a set. Okay, another example of a set may be types of fingers. Index, middle, ring. Look, you can call this as a set of fingers. Just things grouped together with a certain property in common. You should have some property in common. You could not have the hand here, right? Here you have things like whatever you wear. Okay, here only the fingers. Things grouped together with a certain property in common. These are all different types of this. There is a fairly simple notation for sets. The two previous examples, sock, shoes, watch, shirts, etc. is a set. Index, middle finger, ring and pinky. Here the set is very clear because there are no more fingers. Here sock, shoes, watches, it goes on. It's an infinite set, etc. All this means, what do you mean by the term ... here? All this means is that set continues on for infinity. There may not be enough infinite amount of things you add, but and you are not sure about how many things are there. After an hour, you can always come up with bike. You may come up with a pant. You can come up with a briefs. There are a lot of things, right? First, that are called infinite set. The second set we call a finite set. So set has two different things. If you take it in the numerical way, then the set of even numbers, do you remember that? What does this have to do with maths? So the real world, we are bringing into mathematics here. We are putting everything in number. So when we define a set, all we have to specify is a common characteristic. Who says we can't do with numbers? So we represent that in numbers. For example, set of even numbers, -4, 2, -0, 2, 4. Set of odd numbers, -3, -1, 1, 3. Set of prime numbers, 2, 3, 5, 7, 11, 13. These are all sets. Okay, but there are also sets of numbers that have no common trait. For example, you keep on they are just defined that way. 2, 3, 6, 828, 389 may be the house numbers. Your house number, my number. There are no common trait, but they go on. Mine would be 2 by 2, yours would be 6, his would be 7, something like that. They are all randomly banged on my keyboard to produce. Sometimes these numbers are randomly touched in the keyboard. Okay, why are sets important? Sets are fundamental property of math. Word of warning: sets by themselves seem pretty pointless. Set has no point. Okay, only when you apply sets in different situation do they become the powerful building block of maths. Set is just a composition of things, but when you want maths out of it, you need to put it in some way. Okay, graphs, areas, drop, real analysis, complex analysis, lot of things, which gives you all the games, computers, everything. Okay, at first we start with the world things in code, the universal set. Then integers. A universal set for all discussion could be said to be integers. So we can sets of integers like that. In calculus we bring in set. Okay, here is a way of denoting a set. A equal to. Okay, so for example, A is a set, then A is an element in the set. Okay, B and C and C, etc. Now you don't have to listen to the standard. Okay, let us get back to our this thing. Okay, real requirement, what we've been using this for. So with the set, a sequence is very much like a set, but with the terms in order. Look, set may not have a terms in order. We saw that there. Same way, value can appear many times here. Okay, the set may have 0, 1, but a sequence will have many things here. Then we come back to the rule of the sequence. A sequence will have a rule that gives you a way to find the value of each term. So there is a way in which You can find the next term, not in a set. In a set it could be random. We saw that before. Anything can become a set. Okay? But in a sequence there is some meaning. You can come out, there is a way, a process. For example, the sequence C3, 5, 7, 9, etc. starts at 3 and jumps 2 every time. Look, 3 plus 3, 5. 5 is where? 2. You see, then if you put it in the number line, you see 5. Then comes 7. There is an order in the jump. You cannot jump from 3, 7, then 1, something like that. Jumps in orderly fashion. Okay? That order or process is called the rule. The rule should be a formula. You cannot have some rule. Maybe like first time, whenever every second time or something like that. There should be representable in a formula. You know what is a formula, right? You cannot randomly do something based on your moods. Just because you want to add something, that is not a rule. Okay? A formula is the one which is applied universally, equally to all terms and positions. For example, saying starts at 3 and jumps 2 every time. The previous case, we had a rule like that. The rule is starts at 3 and jumps 2 every time. Doesn't tell us how to calculate the 10th term. Right? If you just say starts at 3 and jumps 2, it doesn't say how the 10th pack, 10th size or 5th size or 10th term would be, right? Or 100th term. We want like what would be the 100th term or element would be. Okay? And for that matter, in short, we could call it as nth term instead of saying 10, 11, 12. Any number for that matter. Generic way of saying, universal way of saying is nth term, where n could be any term we want. So if we say n, it could be anything. It applies to 2, 3, 4th position, anything, right? So to depict that, we need a formula with n in it, where n can be any term number. Okay? What is a term? Term is the first term, second term, third term, etc. Do you remember what is a term? Nth term is what? Nth position, nth element, nth member. You can call it anything you want. Okay? Coming here, we have to find that one. Okay?